Hi, good morning everyone. Thank you for joining CSA Global today. My name is Tom Joseph and I'm working as a senior mine planning engineer with CSA Global. I would like to use this opportunity to talk about the common mistakes that I have come across while doing mining audits. I would like to discuss about why is it important to rectify these mistakes and how it will benefit the mining plans. I will also share some examples of similar cases. A long-term plan serves as a framework for making key long-term decisions and setting up the process by which the strategic plan will be achieved. The critical considerations that are missed while doing a long-term plan is usually about the cutoff grade calculations, cost estimations, and the lack of insight into the future potentials. In calculating the cutoff grades, it is quite common to keep it consistent across the operation. The spatial variance of cutoff grade is sometimes neglected, and it is actually quite important in mines with varying geotechnical conditions and haulage distance. It is quite important to review the cutoff grades yearly as the unit cost and financial models changes. Another mistake that I have seen is underestimating the ground support cost and advance rates in a geotechnically challenging zone of the mine. For marginal ore bodies, these misunderstandings and inaccuracy in cost estimations can make a suboptimal plan look like a feasible one. This will cause the wrong prioritization of the resources initiatives and end up affecting the sustainability of the operation. Another mistake is the failure to look the whole operation as one model for cost estimation, especially in mines which got different open pits and undergrounds. Lack of insights into the future are also affecting the strategic decisions that is required to make sure that the company will be thriving down the track. As an example, the underground mines which got longer lives are not considering the future potential of using bigger trucks in the decline designs. The other area that we are falling behind is the upfront consideration of the planning details right from the start of an operation. I would like to share an experience of the impact of changing ground conditions in the schedules. An underground mine was restarting by doing rehabilitation in the decline. The mine required intensive and sophisticated ground support for rehab below 400-meter depth. The rehab rates in the life of mine schedule didn't properly weigh in the time required to install the new and intensive ground support. The actual rehab rates were very low compared to the life of mine schedule, as the operators were less skilled to install the new type of ground support. This slowed down the dewatering rates in the decline as well. The impact of all this delayed the start date of the mine production. Medium-term planning implements policies and procedures to ensure that the short-term problems are not recurring, and it ensures that the mine operations have less unfavorable surprises. Some of the common mistakes found in medium-term plans are using aggressive bogging and backfilling rates, using inappropriate factors and assumptions for dilutions and recovery. Another mistake is that some long-running mines following the scheduling traditions without reviewing over time. For example, using leveling techniques of a scheduling software without putting the right constraints and dependencies. This will end up following a suboptimal mining sequence. Another key element that might be missing from a medium-term plans are the diamondal schedules. Some medium-term plans lack the optimal number of working area available at one given time to achieve the operational efficiency of the equipments. Another key factor that I have seen missing from a medium-term plan perspective is insufficient allocation of operational requirements required for the safe extraction of the ore body. For example, the time required for building paste walls and their curing times are sometimes not factored into the schedules. I would like to show the advantages of including diamond drilling and grade control drilling in the schedules. This is a snapshot of the scheduled solids in an underground mine. As you can see, the diamond drilling activity is included in the schedule. This improves the communication between the departments. the changes in the drilling is actually reflected in the mining schedule. The impacts of delay in drilling and updating the block models can be identified early enough to rectify the issues. The interactions between the drilling and the development is also identified in advance. The importance of including diamond drilling in the mine schedules are quite significant in bigger underground operations. Short-term plans are aimed at how the mine, equipment, and resources can be utilized to reach the production targets. One of the main mistakes that I have noticed is the missed opportunities in short-term plans by only aiming to achieve the medium-term targets, which might have been quantity constrained in the scheduling software. Mine operations must be modeled in a greater details for the short-term horizons. The short-term schedules must include details of the plan like the pace holes, service holes, and cables for development and stopping, etc. The strength of mine planning softwares like ThisWeek can be utilized to include these kind of details into the short-term schedules. The other problem that I have seen is a failure in identifying the changes in haulage constraints. This is more relevant in mines using waste backfill techniques. Once there is no waste backfilling available, the trucking TKMs will be quite high as the trucks needs to transport the waste mine from the development all the way to the waste dumps in the surface. This requires additional trucks to manage the mine production. The other key problem is using inappropriate factors for drill middays for ore passes and slot rises, which inflates or deflates the number of areas available for production rigs. It is recommended to schedule the long-haul drill middays per rigs so that the scarcity in drill sites can be identified and we can prioritize the developments to make more drilling locations available. This is an example of using customized formula for haulage distances for each zone of the mine in order to accurately calculate the TKM. The picture is a long view of an underground mine which have two zones. The starting point of the incline for zone 1 is 2.7 kilometers from the portal and zone 2 is 3.1 kilometers from the portal. For every activity, the formula will calculate the haulage distance depending on which zone it is. The haulage distance is the sum of three components in this case. The first component is the haulage distance from portal to the start point of the internal incline. The second component is the haulage distance from the starting point of the internal incline to the axis of the particular level where the activity is taking place. And the third component is the haulage distance from the start of the level axis to the centralized loading bay in a level. The correct estimation of the TKMs identified the haulage constraints in that mine. It is crucial to identify the mistakes in your schedules and mine plans. Small mistakes in mine plans will end up causing big impacts in the mine production and causes unpleasant surprises. So to conclude, look for mistakes in the schedules and mine plans that stops us from achieving the maximum benefits and rectify it as early as possible. If you need any help in auditing or reviewing a mine plan, contact the CSA Global offices closer to your locations. Thank you for listening to the presentation today. I hope you found this to be informative and I hope you will have a review of your schedules and mine plans and look for any similar mistakes that can be rectified in the mine plans. Thank you.